about inorganic chemistry, test for cations and anions. So basically, before we start, it's always good to know the agents that we are talking about. For example, we have here aqueous ammonia, so-called ammonia solution. We have hydrochloric acid, that is dilute. We have potassium iodide, that is solution from sodium hydroxide solution or aqueous sodium hydroxide. And we are also provided with the source of heat here. We have a source of heat. And apart from that, we have a solid that we need to carry a test on. So the question goes like, now describe the appearance of the solid. So through that, we need to open this particular solid and see. Now in describing the solid, we are supposed to look at the color and if possible, the texture. Now when I'm talking about texture, I mean the roughness or smoothness of that particular solid. Solid. Now, what's the color of this particular solid? White. Now, when describing, you can describe it like this. That now, what about the fineness? Yes, the color is now white. What about the fineness? Is it rough, smooth, or rough? So, like in that case, we're going to say that solid X is a white crystalline solid, right?
Yes.
Okay. So when describing that, you say the texture and also the color. Just two words. It is a white crystalline what? Solid. Now you want to heat. We are told to take a portion of it and heat strongly. So students, I want us to begin with heating, so that you see the color and what is coming out. So I want us to heat this heating. Just some small heating here. And see. So we are going to heat the solid strongly for sometimes. As you watch the color change. Now we are heating. Kindly, we are interested in our observations, so kindly look at what you are seeing. Bob, kindly pick it. Now, are you seeing those fumes coming out?
Yeah.
Which color?
Brown.
Brown fumes coming out. Very good. Brown fumes coming out. Brown fumes coming out. Brown fumes coming out. Now, when you see brown fumes, which conclusion can you make?
Cyanated salt.
Cyanated salt. Very good. Cyanated salt. That simply means that nitrogen. And you can see the brown fumes.
Yes.
You can see them. You see that?
Yes.
So, what is the color of this particular solid?
Orange solid.
Orange. The color of this particular solid?
Orange.
Kadini?
Orange.
It is orange in color. Yeah. So we are seeing that when it is hot, it is orange in color. Now let us just allow it to cool as we go to the next. Thing. So the next thing, the next question is talking about is add or put all solid X in a boiling tube and add about 10 cubic centimeters of what? Distilled water. Distilled water. Now adding, there's about 10 cubic, just approximate. So it's about 10 cubic centimeters. So it is like we are approximating. Now what do? We shake. This is how we shake. You see that? We shake. shaking, we are shaking, we are shaking, we are shaking, we are shaking. Also, it's still hot, so just relax. Now, all the solids now are dissolved. Now, we are supposed to divide into how many portions? 1, 2, 3, 4. Now, 4 portions. 4 portions. You can just add equal amounts, just like this. Into 4 portions, like this. Like that. Like that. Like this. Now, because we have now 4 portions, now which conclusion can we make here? Now, the observation that we're making is that solid X dissolved in water form what? Colorless solution. I think that the color of this particular solution is now colorless. Now, which inference? We have 2 inferences that we can make. Now we can say that colored ions absent. It has dissolved to form a colorless what? Solution. You can see. So that simply means that colored ions absent. Now, when talking about colored ions, we're talking about ion 2 ions, ion 3 ions, or copper 2 ions. Are you seeing that? Those are the colored ions. Apart from that, because we've heated it and we know that it's a nitrate salt, so we can just deduce that it's a soluble salt. It's a soluble salt. So soluble salt present. Are you there?
Yes.
Now, we are supposed to dissolve it in water, then divide it into how many portions? 4 portions. And we are told that the first portion, add ammonia solution dropwise until in what? Excess. So I want us to add aqueous ammonia dropwise and see what is happening. Sasa, now this is how we add drop. Now, what is that? It's a white precipitate. When we add how many drops? Few drops. Few drops. Now let us add until in excess and see if it dissolves or not. Does it dissolve? Does it dissolve? No. So there is formation of white precipitate which does not dissolve in addition of excess ammonia solution. Now to do that, which inference can we make? Now the inferences that you're supposed to make is now writing those particular cations that are present. Now these cations are lead 2 ions, calcium ions, magnesium ions, barium ions. Present? Present. They are present. Right? Yeah. Now to the second question, add sodium hydroxide solution dropwise until in what? In excess. Now we are adding a dropwise. We are adding dropwise. Now dropwise. Now what are you seeing?
Formation of white precipitate.
Now there is formation of white precipitate. There is formation of white precipitate. Now let us add it until in excess. In excess. Now in excess, what do we form? We add until in what?
Excess.
Until in excess. In In excess, you can even pick it like this, and you pour. Are you seeing that? Now this one is what? In excess. In excess. This one is in excess. But we are seeing that it is now dissolving. In excess, it do what? It dissolves to form a colorless solution. So the observation that we're supposed to make or say or write is this. There is formation of wet precipitate which dissolves in addition of excess sodium hydroxide solution to form a colorless what? Solution. There is what? Formation of white precipitate which dissolves in addition of excess sodium hydroxide solution. Are you seeing that?
Yes.
Yeah. Now, inference, zinc 2 ions. Now, remember, here you should not introduce foreign ions. Remember there, when we are using ammonia, we need to introduce what, say? So, we are talking about things that are here now. Because we are using, in quantitative analysis, we usually use elimination method. So, we eliminate these ions one by one. So, because it has dissolved in excess, it means that only 2 ions here are present, and that is aluminium 3 ions or lead 2 ions present. Alright?
Yes.
We are using what? Elimination method. Remember zinc, we didn't put it or we didn't write it when we are using ammonia. Alright? Because zinc, if it was zinc, it could have been what? It could have dissolved in excess amount to give us a certain compound called tetraamine zinc 2 what? Ions. Right? Now, to the fourth portion, to the third portion, we are supposed to add 2 drops of potassium iodide. Now, students, whenever you see, or in the lab, when you see potassium iodide, know that you're testing for presence of lead 2 ions. Right?
Yes.
Lead 2 what?
Ions.
Now, which observation are you supposed to make? We are supposed to see a yellow what? Precipitate. Yellow what?
Precipitate.
So, potassium iodide, let me add some few drops and see, just 2 drops. What am I seeing?
The formation of the yellow precipitate.
Now there is formation of yellow precipitate. Are you seeing that?
Yes.
Yeah, there is formation of yellow precipitate and you can see. So that is good. Now, we are heading somewhere. Now, when we see that there is formation of yellow precipitate, which inference we write? Lead 2 ions, lead 2 ions present. Lead 2 ions present. So potassium iodide in the lab is used to test for presence of potassium or lead 2 ions. Lead 2 ions. So you can make a conclusion there. So our next thing is on the third thing that we have here is now we add hydrochloric what? 2 drops of hydrochloric what? Acid. Now hydrochloric acid. Now HCl in the lab test for lead or what? Silver. You see that? So when we see if there is formation of white precipitate, then you need to know that either lead or silver is present. But because in quantitative analysis we are using what? Elimination method. Kindly stick to what we have. Remember we have lead 2 ions or aluminium, but this potassium iodide has confirmed to us that it is what? Lead. Alright? So we need to form something called, we are going to form something called now white precipitate. We are supposed to form white precipitate. So let us see. So this is the white precipitate we are talking about. This is now the white precipitate that we're talking about. So it is lead 2 chloride. Lead 2 chloride. Remember all chlorides are soluble except that one of lead. Or what? Silver. And lead 2 chloride is soluble on more. And if you want to do that, you can warm it. But remember, it is not in our procedure. It is not in our procedure. When it dissolves, it means that the 2 ions present because the 2 chloride is soluble on warming. Now, students, let us look at what we heated here because it has now cooled. You can see. Remember, there was formation of what? There was formation of brown fumes, indicating that the salt is what? A nitrate. Nitrate. And orange solid was formed when hot. And now, what is the color now here?
Yellow.
Are you seeing that?
Yes.
It is?
Yellow.
It is a yellow solid. It's a yellow solid. It's a yellow.
Solid.
It's a yellow solid. You can. It's a yellow solid. Now, which observation can you make there? Because when you are given such kind of question, the observation, the part for observation will be 2 marks. So you're supposed to say. So the observation that you're supposed to write is that there is formation of brown fumes. Full stop. Another thing that you're supposed to write is that there is formation of orange solid when hot and yellow when cold. Now through that you qualify for those 2 marks. Now under inference, you're supposed to say that lead 2 ions present, nitrate ions present. Are you there? Yes. So I think that's how just for this particular inorganic compounds. So in our conclusion, we are supposed to know how to test cations using ammonia solution, using sodium hydroxide solution, and if possible, potassium iodide, and HCl. Now, we have other reagents that we're not given, and such kind of reagents when you're given, yeah, you'll be required maybe to write your observation. For example, we have lead-2 nitrate that we're not given here. We have nitric 5 acid and also barium nitrate. Those ones test for anions. Remember, they test for what? Anions. Now, anions are negative interval what? Ions. Alright? Now, the anions that we have that you can test in the laboratory, we have sulfates, we have chlorides, sulfides, carbonates, hydrogen carbonates. Are you there? Yeah. So, there's no big deal there. I think that's the end of the lesson. So, at the end of the lesson, it's always good to clean everything. So I will require you to clean on this